This is the second elasticity problem I'm making up for you. This is if you have a problem with a function, and for example, you could have Q, which is quantity sold, as a function of the price. And let's say it's 10,000 minus 1/3 P cubed minus 1/2 P. And you're going to find out why, actually, why we always use parabolas, because this function is quite obnoxious. It's not that it's obnoxious to deal with, it's that the values you get end up being quite obnoxious. So any Q function that is going to look like that. Okay, any Q function is going to be strictly decreasing. This may not be showing as strictly decreasing, but I just meant it to be wiggly. It's going to start at some positive y-intercept and it's going to go down. So as your price goes up, eventually you're going to sell none. Okay? And then here, this is the giveaway. Right? You can only give away so many of these objects, and then when you raise the price, you're going to be able to give away less of them until people won't even take them. So that's what your function is going to basically look like. Okay, I want you to calculate elasticity of demand for P is equal to 10, 20, and 30. And I didn't just pull those numbers out of the air, although it looks like I did. Actually, I went back, I made up this problem so that those values would work. Okay, so you start with your function, or your equation that you get off your formula sheet. P over Q. All right. And remember, the absolute value sign, this just means you get to drop the first negative sign you find. Okay, dq dp comes from here. dq dp, or if you prefer to write it q prime, this 10,000 disappears. Then you take 3, multiply by 1/3, so you just get minus p squared, and then you just get minus 1/2. Okay? That looks pretty much like a negative sign that I want to get rid of. So I'm going to go over here for elasticity, and I'm going to say p squared plus 1/2. There, I've gotten rid of the absolute value sign now. Now I just need p over q. P is just p, and q is right there. So it's 10,000 minus 1/3 p cubed minus 1/2 p. There you go. All right, so now all we have to do, and we could rewrite it if you want, it's not necessary, but let's calculate elasticity at 10. Okay, so I guess I will rewrite it. It'll save me a little time. P cubed plus p over 2, and the denominator is 10,000 minus 1/3 p cubed minus 1/2 p. Okay, so E of 10 is 10 cubed plus, what's 10 over 2? It's 5. And then you have 10,000 minus 1/3 of 1,000 minus 1/2 of 10, which is 5. Now something you should be looking at. This term, 10 cubed, and this 10,000, those are the important players, right? I mean, this 1/3 of 1,000, oops, 1/3 of, yes, 1/3 of 1,000 isn't going to really matter that much. So this number is going to be really small, because 10 cubed is small compared to 10,000. So you type all this into your calculator, and I'm not going to do it on the screen for you because it's going to waste time. But I did this, and this is essentially what I got. So it's not elastic. That means you can crank up the price. And remember, this is in units of price. I didn't say that. I did, I guess. Okay. Well, what happens at E of 20? So it's going to be 20 cubed plus half of 20. 10,000 minus 1/3 of, right, so this is 20 cubed. So you know what, let's just write it as 20 cubed. Let's not try to figure it out. Half of 20 is 10. Type that into your calculator, and this is kind of a mess. You might want to do the numerator separate from the denominator and write that value out, and then go ahead and calculate it. If otherwise, here's where I would suggest putting your parentheses, and then you put a divide by symbol. I will put parentheses here when you type it in. Of course, there's going to be a little exponent here, then you can have a divide by between the two layers. That's pretty much it. If you put those parentheses in, it'll probably protect you from all harm. Right, so this guy is 1.09376, and at this point, revenue is roughly maximized. Okay, so just as a point of reference, we consider it to be ever so slightly elastic. Okay, but you probably don't want to push that price up much higher than that. Now what about E at 30? So E of 30, you're going to end up with, okay, I'm not going to write that up, but you're going to get 27.4264. This is very elastic, and what's happening here is you're getting very close to this point in the price structure where you're not going to be selling any. That means if you want to sell any, you have to lower the price. So here's the thing, at the value around 31 is roughly where you sell nothing. It turns out if you just solve this guy, it's roughly $31 in some odd cents. You're not going to sell any at all. Okay, so let me show you a picture of what's going on here. When you have a p function, just generically, some kind of p function like this, and then you multiply by q, what does pq look like? Well, wherever the 0 occurs here is going to still occur down here, but the pq function, so the total revenue, all right, is always going to have a 0 when you sell nothing, and when, so over here you sell none, and here's the giveaway point. All right, so in both cases you get no revenue. So all that's happening is you're taking p and you're multiplying by q, which is a straight line. Let me draw a straight line. So there's q. That's all you're doing, is you're multiplying by that. So that means you're forced to have some kind of max occur somewhere in here. And we found out just by looking that it was around 20-ish. Okay? And down here was around 30-ish. So this is not drawn to scale, it's just showing you there's got to be a max somewhere. Because if you give them all away, you get no revenue. And if you don't sell any, you get no revenue. And in the middle, you get positive revenue. So there's got to be a max somewhere. That's all it's saying. And that's all we're doing. And this elasticity is just another way of figuring that out. And right here, it's very, very elastic because you're very close to selling nothing. So you better drop that price back down to 20 or you're not going to be selling anything.